Hey everybody, so today in class we started talking about how do we actually conduct psychological research, and we learned that the first thing you have to do is you have to ask a question or be curious about something. So I'm curious about happiness. What causes happiness? Is there anything that relates to happiness? If I have it, am I more happy? If I don't have it, am I less happy? So the first thing I have to do is I have to do a descriptive research method on it. Either a case study, survey, or naturalistic observation, or all three, in which I gather as much information as I can about happiness. So maybe I do a case study on a couple different people who I believe are extremely happy, and I try and write down what are the things that I think are influencing their happiness. I may give out a survey to a random sample of people and ask them how happy they are, what things in their life do they believe impact their happiness. And I know we didn't get to naturalistic observation, but we'll cover that in class tomorrow. So after gathering all my data, I start to realize, it tends to be that people with bigger families tend to be happier on my initial data. So let me see if those two things are actually related or if that's just something that came up in my data. It just doesn't really mean anything. So that's where we move into the correlational research. Correlational research is a relationship between two variables. So my two variables might be your level of happiness and your family size, how many people actually live in your house. Now, the strength of doing correlational research is if I find that there's a relationship between the two variables, I can predict things. So if I meet someone on the street and I'm like, hey, how many people do you have in your family? And they say 10, I can probably predict their level of happiness. The weakness of it, though, is that correlation doesn't mean causation. Just because two things are related doesn't mean they cause one another. So it might be that people with bigger families are happier, but it doesn't necessarily mean the size of the family is what's making them happier. Maybe it's their faith. Maybe it is their income level. Because they have a higher income, they're able to have more kids. So it could be a number of different things. And so those are things to keep in mind with correlational research. Here are some other examples of variables that could be used in correlational research. So for example, maybe I think that height and weight are related, and so I want to do a study on that. Or your golf score and the number of years that you've played golf. Or maybe I want to see if there's a relationship between your IQ score and the size of your big toe. Okay, I can pick any two variables I want. I just need to see, is there a relationship between the two of them? So let's say that I pick two variables. We'll just do height and weight. What we need to do is we need to create what's called an operational definition. Okay, what do I mean by height? What do I mean by weight? Am I going to measure height in inches? Am I going to measure height in centimeters? Am I going to measure weight in pounds? Am I going to measure it in something different? I mean, I have to be very specific on how I define my variable. And the purpose of this is because if research is going to be taken seriously, it has to be able to be replicated. And it can't be replicated if the other psychologists and scientists don't know how you actually defined your variable. Also, creating operational definitions gives you a way to get a number for your variable. So let's say that I'm doing my original two variables, happiness and the size of your family. Well, how do you quantify happiness? You can't do it. You have to put it into a numerical form by like way of a scale or something. So I might say, rank your happiness level on a scale from 1 to 10. Now I actually have a number, and I've taken this subjective thing that's happiness, and I've made it into something that's very mathematical and quantitative. Here's another example. Let's say you're trying to find out if chocolate causes violent behavior. Well, what do you mean by chocolate? Hershey Kisses, milk chocolate, dark chocolate, white chocolate, organic chocolate, fake chocolate. I mean, like, what are you talking about here? In order for the study to be replicated in a perfect way, you have to be specific. What do you mean by violent behavior? Is flicking someone in the ear violent behavior? Is punching someone in the face violent behavior? Where do you draw that line? Okay, and like I mentioned earlier, it's important to make sure that the study is replicable, reproducible, and valid. So here are those original variables that I gave you a couple slides ago and how you potentially could operationally define them. So for your IQ score, there are a couple different IQ tests you can take. You've got to be specific about which one. Size of your big toe, we're going to measure it in millimeters from the top of your joint to the top of your toe. Salary, that includes bonuses and benefits. Okay, it's not just what your paycheck is. And then, like I said, happiness on a scale from 1 to 10. And there's no one right operational definition for any of these variables. You could have defined it differently. But whatever you choose has to be written down and you have to stick to it so that it can be. Sorry, the announcements came on. I got a little distracted. Okay, so now that we have our two variables, they've been operationally defined, now we collect data about their relationship. So I make a T-chart with my two variables. Let's say I choose golf score and years played. And now I just go ask a bunch of people, hey, what's your golf score? How many years have you played? Once I feel like I have a large enough, representative enough sample, then I go and I plot it on a graph. And I have really three options that it can come out looking. It can come out looking having a positive slope, a negative slope, or really no slope at all. What we say that this first graph is, it's a perfect positive correlation. This is a perfect negative correlation, and this shows that there's no relationship. Very rarely in real life will you ever get data that is a perfect positive correlation or a perfect negative correlation. But those are just kind of the extremes so that you know what those look like. So what is a positive correlation? A positive correlation is when the variables go in the same direction. Okay, so let's say I look at my golf data and I find out that the higher number of years that you've played, the higher your golf score. Okay, now that doesn't really make sense because usually in life, if you're better at golf, that means that you've played, your score is lower. But it's possible that they could be going in the same direction. Or it could be the lower your golf score, the lower amount of years that you've played. So another example not related to golf that might make more sense is that the more you study, the higher your grades usually are. The less you study, the lower your grades usually are. Even they're just going in the same direction. Even though the one is going down, it's still the same direction. So it's really important not to get confused thinking a positive correlation means they're both going up. Another example is the more education you have, the more money you usually make. The less education you have, the less money you make. So then a negative correlation, that means the variables move in opposite directions. So this makes more sense with golf data. Usually, the higher number of years you play golf, the lower your golf score, the lower your handicap. The higher the temperature is outside, the less clothes that you wear, opposite directions. An example for school, the more you do drugs, usually the lower that your grades are, okay? Another thing that you'll get with correlation data charts is this thing called a correlation coefficient. And it's a number that you're not going to need to know how to solve for, but you're going to need to know how to interpret it. So the number has a range from -1 to +1. It could be anything in between. The positive or negative sign tells you the direction of the relationship. So if it's a positive number, it's a positive correlation. If it's a negative number, it's a negative correlation. The stronger the correlation, the closer the number should be to 1 or -1. The weaker the correlation, the closer it is to 0. So again here, the positive sign tells you the direction of the relationship, and then this number tells you the strength of the relationship between the two variables. How strong of a predictor is it if this variable goes up? Is the other variable going to go up as well? So a 0.37 isn't that strong of a correlation coefficient. Here are some examples of strong and weak correlation coefficients. So in our case, we classify anything from a 0.7 to a +1, this is positive or negative, as a strong correlation. Okay, so you can see these are very strong correlations here on the bottom. This is a 0.9, and this is a -0.99. This is almost a perfect negative correlation. Even though it's negative, it's still a very strong correlation because as one goes up, one's going down. Here we get into more moderate ones. So you can see there's still a negative correlation here. A little bit of a positive correlation here. Absolutely zero relationship. You can see there's no correlation coefficient. And then here is a 0.3 correlation coefficient. Not a lot of relationship between these points here. So here's a quick quiz for you. Which one of these correlation coefficients in each bullet point is stronger? Is -0.13 stronger than +0.38, or is +0.38 stronger than -0.13? The answer is +0.38 because it's closer to 1 or -1. In this case, it's closer to 1. This is closer to 0, so it's weaker. In this case here, -0.72 or +0.59. The stronger correlation is the -0.72 because it's closer to 1 or -1. This one's closer to 0. And then finally here, -0.91 or +0.04. This is a very weak correlation. There's almost no relationship between the two variables, so this is definitely strong, almost 100% correlation. Here's some other examples of real correlational research. So this is your first year GPA and your total SAT math and verbal score. As you can see, there tends to be a positive correlation between the two variables. The higher your SAT score, the higher your first year GPA at the University of Virginia School of Engineering. They also did a study on your spring semester GPA versus your fall semester GPA. Again, a very positive, strong, looks like very strong correlation. The higher your fall semester GPA tended to be, the higher your spring semester GPA tended to be. So this is where we're going to stop for this video. I just wanted you to see how correlational research fit within the broad scheme of this whole research process in psychology. I wanted you to understand how you pick variables. What is a variable? I wanted you to understand operational definitions, and I wanted you to understand the difference between a positive and a negative correlation, and also a correlation coefficient. When we get in class, we'll talk more about correlation not meaning causation and illusory correlations. So I will see you tomorrow.